back to a brand new video. Today we are going to learn the circuit simulation in a Matlab. So we will learn about different types of concept here, like course overview. First we will see the course overview, then we will go to RC and RLC circuits, then nonlinear elements, then op-amps, filter circuit, and project, which is Wayne bridge oscillator. So let's move towards the simulation course overview. Let's start the course.
Hello and welcome to Circuit Simulation On-Ramp. This course will introduce you to simulating analog circuits using Simscape. Simulation helps you both understand and design circuits. For example, you can use simulation to understand the contribution of various circuit components to the overall system response. Or you can use it to validate a design against specified goals. With Simscape and Simscape Electrical, you can simulate a wide range of circuits with realistic effects, like operating limits and noise. Throughout this course, you will build many circuits that you've likely seen before: bridge rectifiers, inverting amplifiers, and low-pass filters. You'll start by building RC and RLC circuits and observe their response to both DC and AC inputs. Then you'll incorporate nonlinear components and op-amps to make more advanced circuits. You'll also learn how to measure and understand the frequency response of filter circuits and use them to remove noise from a signal. At the end of the course, you will build an oscillator circuit that generates a sinusoidal output. You don't need to learn a lot of theory to start simulating electrical circuits, but you'll get the most out of this course if you're familiar with the types of circuits mentioned in this video.
Yes, because I'm an electronical and telecommunication engineer, or you can say I'm a student who is currently studying in the electronic and telecommunication field. I know about all of these circuits.
It will also help if you know a bit about Simulink and Simscape. You should be comfortable with adding and connecting blocks, branching signals, and modifying block parameters, as well as how Simulink and Simscape interact. If you've never used these products before, or you want to refresh these skills, we recommend you first take Simulink On-Ramp and Simscape On-Ramp to get you up to speed quickly. Throughout the course, you'll be completing tasks in the Simulink editor. It's the same Simulink you'll encounter outside this training, but with a few added features. Tasks will appear on the left and feedback on the right. If the assessment involves a block value, it will be displayed in the feedback area as well. Enjoy the course!
Okay, so let's start the course. We will only do the 20% of course today, and I will complete this course tomorrow completely. Okay, because I have to make different types of circuits in Matlab. Currently I am working on a protocol, so I have gave the name Dave protocol to a protocol that I am making. Basically it is just like a UART protocol, but instead of two different types of connection for communication between master and slave, what I am doing, I am using only one bus which will act as a half duplex protocol, which can communicate from master to slave and slave to master, and it has the efficiency, and you can say it has the noise reductancy like CAN bus, because I am using some special type of feature there. Okay, so we will talk about that later. Let's start the course. In this task you will be assessed on the voltage V on. Okay, the plot in the assignment plane also display the input voltage. Click submit and run the model. Now next, double click the block labeled high frequency. So high frequency, and change the frequency parameters to 1000 hertz. All right. But you should notice that the notice that the signal looks more like a pure 120 hertz sine wave signal. Okay, see about that later. Let's start. Sorry, let's run the. Yes, now it is like a sine wave. Let's go to the next task. The filter performance can be improved by adding additional component in the SimScape. It is simple to modify or extend your circuit design. Set the frequency of the block level high frequency. Ah. Set the frequency of the block level high frequency back to 500 Hertz. 500 Hertz. Copy paste the inductor and capacitor as shown below. Okay. With SimScape is like a headache because the components are not that much movable.
SimScape Electrical adds additional capabilities to SimScape, allowing you to model at scales from semiconductor devices to power grids and everything in between. SimScape Electrical blocks exist in their own library. This library contains realistic implementations of electrical components, such as electric motors, integrated circuits, and mechatronic actuators. SimScape Electrical also has many of the same components available in the SimScape Foundation library, but with more customization options. For example, the SimScape Electrical Capacitor includes higher fidelity features such as part tolerances and fault detection. You can use blocks from either library in your models to get the level of detail that you need. So, how do you know whether you want to model your voltage source like this, or like this, or this, or this? And what about this one? Why does it look different from the others? Let's talk about block color first. SimScape electrical blocks with black icons are specialized power systems elements.
Okay.
You can use them to model power systems like three-phase electric grids or AC motors.
Okay.
But we won't cover that in this course. For now, you'll always be looking for blue components, including components in the SimScape Foundation library. So how do we choose an appropriate block for our simulation? It's a good practice to choose the simplest block that captures the behavior that you need. Let's take another look at the voltage sources to see how we would choose a block to represent a constant DC voltage. Based on the name alone, these two are more complicated than we need. We don't need a pulse source or a piecewise linear representation. These last two, though, well, they look the same. Let's take a look at their block parameter dialogues. We can see that both blocks allow you to specify a constant voltage. The voltage source has additional parameters for AC and noise components, but we don't need those. So we'll select the DC voltage source since it does what we need and nothing more. If this selection process seems a bit daunting, that's okay. In this course, you'll learn how to select blocks for different applications. Let's get to modeling.
Oh. Now, what I have to do? Add a solver configuration. Solver configuration from the SimScape utility and electrical reference. So I will just write reference, electrical reference from SimScape Foundation Library, electrical and electrical elements. So SimScape Foundation Library from electrical and electrical reference. Next, add a DC voltage source. Am I right? Yes. DC voltage source. Not this one. DC voltage source. Resistor. So wires. Electrical elements. Resistor from electrical elements. Simscape electrical elements. There are lots of resistors already present here. I'm going to choose this. Next, capacitor. I'm going to choose the foundation library. Now what I have to do, I have to rotate it like this. Then I have to make it perfectly connected to each other. Let's make a perfect circuit. DC voltage, set it to constant 10 volt. 10 volt. Okay. Set the value of resistance to 100 ohms. 10 ohms. 10 ohms. And set the capacitance value to -5 farad. Next, what I have to do, connect the block to create the series of okay, connect the block to create the series of RC circuit. Arrange the capacitor and resistor block so that each block logs a positive voltage drop. When you run or submit this model, the capacitor voltage will be displayed as assisted. Use the Simulink tool script. Set the stop time to 2e minus 3. Yes, stop time is 2e minus 3. Next, add an inductor from foundation library. Instead of capacitor, I will use the inductor. Disconnected and set the inductance to 1.5 e minus 3. Inductance to 1.5 e minus 3 Henry. Now I have to click on submit. Does the following block values match the plotted requirement B? Okay, so I have to attach the capacitor also here. From foundation library, control R, sorry, control R. Now it is perfect. So as you can see, because of the inductor and capacitor, first the voltage is charged, then because of the inductor, at this point the capacitor is charged and the inductor also charged, then capacitor drop, but the inductor will give the power, and it will be in this series, means this is the point where capacitor get discharged and inductor gives the power, and this is the highest point where the capacitor can charge. Next, add a resistor, inductor, capacitor and electrical reference. Inductor and capacitor. Capacitor from the foundation library, and set the value to 200 ohm. The value of inductor is 0.5. No, the value of inductor will be 25 millihenry. 25 millihenry, and the capacitor will be 0.25 macrofarad. Okay, no, it is 0.5 macrofarad. 0.5 macrofarad. Submit. Does the model contain the following? Okay, electrical reference. Electrical reference. Next task. Add the switch block. From foundation library to your model. Next. Open the block parameter dialog. Open the block parameter dialog for the capacitor block. Check the capacitor voltage. Check the capacitor voltage blocks. Allow edit option and change the value to 5 volt. 5 volt. Now connect the block to create the series of RLC. So first there will be resistor, then there will be a conductor, then there will be a capacitor. With this we can create the RLC combination. This is the electrical reference and this is for the configuration. Let's see the solution. Okay, so I have to connect the switch also. Okay, so capacitor is wrongly connected. It has to be like this. It is perfectly. You can see plus minus plus minus plus minus, which is connected to ground. Resistor. This is conductor. So this is capacitor. everything is connected to ground. Should I connect ground here? See, this is completely connected, I guess. Yes, it is set to the 5 volt. Okay, so problem here is that I have to go to this part, 5 volt. Now let's go to the next part and add a PS block. The PS block, set it to the step time. It was set the time. Step time. I cannot. Oh, PS step block. Sorry. PS STEP step block, and we have to connect the step time to 0.5 E minus 3, and we have to connect this to here. I will make this more perfect. Like this. Okay. Okay, so with this I have completed the 20% of the course, and okay, it is a bit interesting, that's why I'm going to solve more problems. Capacitor from passive library. Okay, next open the dialog parameters. Hmm, Tolerance application to change the tolerance application to apply maximum tolerance value. This will change the capacitor value to this. Okay, next. I think I can complete this course today itself, but add an AC voltage source from the electrical foundation library. Connect the positive output terminal to the capacitor, and then I just have to do the grounding, and then I have to connect the electrical reference and the solver configuration. That's all. Next, add the voltage sensor and a PS. Okay, connect it with the parallel with capacitor. It is PS and scope. Scope. At the current sensor, to the model connected in the series with the capacitor. So let's connect this with the series with the capacitor. The PS not connected to the current being in the output. Now, next thing, name the simulated signal current and the voltage. Current, voltage. Okay, so instead of using two different types of scope, we have to use one single scope with the legends on. Okay, so I have to go to the home page. After that, we have to go to settings. Then we have to go for output. Will be number of input will be 2. Display, show legends. That's all we need. Now I will delete this scope and I will connect this part of the signal here. This bit perfect. Submit. Yes. Now you can see the result in the scope. There are two different types of signal, which is current and voltage, as you can see. Sorry. Next step.
You've just seen how to model RC and RLC circuits in SimScape. This component-based approach makes it easy to assemble and modify the circuit and quickly observe its response in simulation. This is helpful, but we could have found these solutions by hand. You've probably derived these equations before, using Kirchhoff's laws and the constitutive equations for each component. The result is a simple closed-form solution. In other words, an equation for how the circuit responds over time. Other circuits, though, either don't have such solutions or they're difficult to derive. In these cases, you'll especially want numerical simulation, which is where Simscape Electrical comes in. Let's look at an example. A diode is a common component that allows current to flow in only one direction. It has a nonlinear current-voltage relationship. If you try to solve the equations for a circuit containing a diode, you'll see that it's not possible to obtain a simple time response.
Yes.
Using Simscape Electrical, though, you can easily simulate this circuit and observe how the diode current responds to the input voltage. The Simscape Electrical library contains many other nonlinear elements to help you simulate realistic circuits. Just by adding the relevant blocks, you can model faults, switching events, and hysteresis. Since we can test these effects in simulation and predict their real-world consequences, we can design around them.
Okay, so that's for all today. We will meet again in the next video tomorrow.